Assalamualaikum. My name is Wan Kesatina Kamilia binti Muzammil. Today I would like to present about a safety officer briefing on occupational safety and health or OSH and highlight for NMK IC Design Sdn Bhd. The purpose of this briefing is to increase awareness of workplace safety, explain legal responsibility under OSHA, and introduce HIRAC as a tool for managing workplace hazard and risk. Let us understand who a safety officer is. Under OSHA 1994 Section 29, employees in high-risk industries are required to appoint a competent safety officer. The main duties of a safety officer include conducting HIRAC assessment, inspecting workplace safety, investigating accidents, communicating with DOSH inspectors, and providing OSH training to employees. This briefing is important because Nano KIC Design Sdn Bhd will undergo a DOSH compliance audit in 4 weeks. Currently, no complete HIRAC assessment has been conducted. Workers have limited awareness of their legal duties, and management requires better understanding of OSHA obligations. Therefore, this briefing aims to educate everyone on OSH requirements and prepare the company for the upcoming audit. Occupational safety and health (OSH) is important because workplace accident can have serious consequences. According to DOSH statistics, more than 60,000 occupational accidents were reported in Malaysia in 2022. In the same year, 1,154 occupational fatalities were recorded. Workplace accident also caused economic losses exceeding RM44 billion annually. Besides financial losses, accident can lead to injuries, disabilities, reduced productivity, legal penalties, and damage to a company's reputation. Therefore, investing in workplace safety is not only a legal requirement but also a smart business decision. Now let's discuss about the employer duties under Section 15 of OSHA 1994. According to this section, employers have a legal responsibility to ensure the safety, health, and welfare of their employees while at work. There are 5 key duties that employers must fulfill. First, Section 15A, Safety Plan and System. Employers must provide and maintain machinery, equipment, and work systems that are safe and do not pose health risks to employees. Regular maintenance and inspection are important to ensure that equipment remains safe to use. Second, Section 15B, Safety of Chemical and Substances. Employers must ensure the chemicals, hazardous substances are used, handled, stored, and transported safely. This is particularly important in workplaces such as nanocare, where employees may be exposed to hazardous chemicals during daily operations. Third, Section 15C, Information and Training. Employers must provide sufficient information, instruction, training, and supervision to employees. Workers need to understand workplace hazard and know how to perform their tasks safely. Fourth, Section 15D, Safe Place of Work. Employers must maintain a workplace that is safe and provide safe access and exit routes. This includes keeping work areas clean, organized, and free from hazard that could cause accidents. Finally, Section 15E, Safe Work Environment. Employers must provide a working environment that is safe, healthy, and equipped with adequate welfare facilities. Examples include proper ventilation, emergency facilities, clean rest areas, and access to first aid. While employers have many responsibilities under OSHA 1994, employees also have important duties to ensure workplace safety. Let's now look at the responsibilities of employees under Section 2024. There are 4 key responsibilities that every employee must follow. First, Section 24A. Employees must take a reasonable care of their own safety and health, as well as the safety of others who may be affected by their action or negligence. For examples, workers should follow safety procedures and avoid unsafe practice that could cause accident. Second, Section 24B. Employees must cooperate with their employer and any authorized person in carrying out safety and health requirements under OSHA 1994. This includes participating in safety training, following workplace rules, and assisting during safety inspections or investigation. Third, Section 24C. Employees must wear or use any protective equipment or clothing provided by the employer whenever required. Examples include safety helmets, gloves, goggles, face shield, respirators, and protective clothing. PPE should always be used correctly and consistently. Finally, Section 24D. Employees must comply with any safety and health instruction, procedure, or measure established by the employer or authorized personnel. This includes following standard operation procedure, emergency procedures, permit to work system, and other workplace safety requirements. In summary, workplace safety is a shared responsibility. Employers provide a safety working environment, while employees must effectively follow safety rules and cooperate in maintaining the environment. Now that we have discussed the responsibility of both employers and employees under OSHA 1994, let's examine the latest OSHA 2022 amendments and how these changes strengthen workplace safety enforcement. Let's discuss the OSHA 2022 amendment, which introduced several important changes to strengthen workplace and health in Malaysia. The first major change is higher penalties. Under the amendment, penalties for safety violation have increased significantly. Individual fines can now reach 500,000 ringgit compared to 50,000 previously. Companies may face fines up to RM3 million and imprisonment period have also extended. This change emphasized the seriousness of workplace safety compliance and encouraged organizations to take proactive measures to prevent accidents. The second change is Mandatory Safety Management System, or SMS. High-risk industry including semiconductor, manufacturing and chemical handling sectors are now required to implement a formal safety management systems. This ensures that safety is managed systematically rather than only reacting to incidents after they occur. Third change is extend scope of OSHA. Previously, some sectors were not fully covered under OSHA 1994. The amendment now expands coverage to include all sectors, including public service, educational institutions, and industries that were previously excluded. Finally, the amendment introduced enhanced enforcement power. Dodge inspectors now have greater authority to investigate workplace and the premises, examine records, and seize evidence when necessary. They can also issue immediate stop work orders if serious safety risks are identified. Overall, the amendments demonstrate the government's commitment to creating safer workplace and ensuring stronger compliance with occupational safety and health regulation. For organizations like NanoCare IC Design, compliance is no longer just a recommendation, it's a legal obligation with significant consequences for non-compliance. Besides complying with legal requirements, engineers also have an ethical responsibilities to protect the safety, health and welfare of workers. Let's now examine the BEM Code of Ethics and its role in engineering practice. Will explain the BEM Code of Ethics and Engineering Responsibility. As engineers, our responsibility is not only to design and develop technology, but also to ensure the safety and well-being of workers, the public and the environment. The first principle is public safety is paramount. This means that safety must always come before cost, production targets, or project deadlines. If an engineer decision could create a safety risk, we must prioritize protecting people, even if it increases cost or causes delays. The second principle is professional competence. Engineers must continuously improve their knowledge and skills, especially in occupational safety and health. Since NanoCare IC design handles advanced process and potentially hazardous chemical, engineers must understand the relevant safety requirements and follow industry standards. Engineers must report hazards, incidents, and safety issues truthfully. We should never hide risk, false inspection result, or provide inaccurate information. Accurate high-rank assessment are essential for preventing accidents and ensuring compliance with safety regulations. The final principle is continuing duty. Safety is not a one-time activity. Engineers and safety officers must regularly review workplace hazard, update assessment, and improve safety measures when necessary. Continuous monitoring helps ensure the workplace remains safe as a process and technologies touch. In conclusion, the BEM Code of Ethics reminds us that engineering is not only about technical excellence but also about protecting lives through responsible and ethical decisions. Now let's discuss about MS 1722-2011, which is the Malaysian Standard for Occupational Safety and Health Management System. This standard provides a systematically framework for organizations to manage workplace safety and health effectively. The system consists of 5 main elements. First is policy. Top management must establish a written OSH policy that demonstrates the organization's commitment to safety and health. The policy should be communicated to all employees and reviewed regularly to ensure its effectiveness. Second is planning. At this stage, the organization identifies workplace hazards through hierarchy, review legal requirements, and establish safety objectives and action plans. Proper planning helps prevent accidents before they happen. Third is implementation. This involves assigning roles and responsibilities, conducting safety training, and preparing emergency response procedures. Employees must understand their responsibilities and know how to respond during emergencies. Evaluation. The organization monitors safety performance through workplace inspection, incident investigation, internal audits, and key performance indicators. This helps determine whether safety measures are working effectively. Finally, management review. Senior management reviews the overall OSH performance, evaluate the effectiveness of the system, and make decisions for continuous improvement. This ensures the organization continues to improve its safety standards over time. In summary, MS 1722-2011 provides a structured approach to managing workplace safety by following the cycle of policy, planning, implementation, evaluation, and management review. To better understand how continuous improvement works within the system, let's look at the PDCA cycle in OSH management. The PDCA cycle, which stands for Plan, Do, Check, and Act. The PDCA cycle is continuous improvement process used to manage occupational safety and health effectively. The first stage is plan. At this stage, the organization establishes its OSH policy and objective. High-risk assessments are conducted to identify hazards and assess risks. The company also reviews legal requirements and develop actions plan to improve workplace safety. The second stage is do. This is where the planned safety measures are implemented. Examples including installing engineer controls, introducing administrative controls, providing personal protective equipment or PPE, conducting OSH training, and preparing emergency response procedures. Safety data sheets or SDS should also be made available for chemical handling activities. Third stage is check. After implementation, the organization evaluates the effectiveness of the safety measures. This is done through workplace inspection, internal OSH audits, incident investigation, near-miss reviews, and monitoring safety performance indicators. The final stage is act. Based on the findings from the evaluation stage, corrective actions are taken to address any weakness or gaps. Management reviews the result under the hierarchy if necessary and sets new target for the next improvement cycle. At the center of the PDCA cycle is continuous improvement. This means workplace safety is not a one-time effort but an ongoing process that requires regular monitoring and improvement. In summary, the PDCA cycle helps organizations systematically plan safety activities, implement controls, evaluate performance, and continuously improve their OSH management system. Now that we understand that continuous improvement process, let's move onto hierarchy and understand how hazards risk controls are managed in the workplace. It is hierarchy. Hierarchy, which stands for hazard identification, risk assessment, and risk control. Hierarchy is one of the most important tools in occupational safety and health because it helps organizations identify workplace hazards, assess their risks, and implement appropriate control measures before accident occur. The first step is hazard identification or HI. This involves systematically identifying all potential sources of harms in the workplace. Hazards can be physical, such as moving machinery, chemicals such as hazardous substances, biological such as a bacteria or viruses, ergonomic such as a poor workstation design, or psychosocial such as work-related stress. The second step is risk assessment or RA. Once hazard has been, the step is risk assessment or RA. Once hazard has been identified, we evaluate the level of risk associated with each hazard using a 5x5 risk metric. Risk is calculated by multiplying the likelihood of an incident occurring, the severity of its consequence. A score between 15 and 25 indicate a high risk, 5 to 12 indicates a medium risk, and 1 to 4 indicate a low risk. The final step is risk control or RC. After assessing the risk, suitable control measures are implemented following hierarchy of control. These include elimination, substitution, engineering control, administrative controls, and personal protective equipment or PPE. The goal is to reduce the risk to an acceptable level and create a safer working environment for everyone. In summary, HIRAC helps organizations proactively manage workplace hazard, prevent accidents, and comply with legal safety requirements. Now that we understand the components of HIRAC, let's look at the HIRAC process flow and see how these steps are applied systematically in the workplace. Let's take a look at the HIRAC process flow, which shows the step-by-step approach used to manage workplace hazards and risks. The first step is to identify and classify all work activities carried out in the workplace. For example, in the chemical storage and CMP areas, activities may include chemical handling, storage, transportation, and equipment operation. Step 2. Identify hazard. Next, we identify all hazards associated with each activities. This hazard must be chemical, physical, electrical, ergonomic, or other hazards that could cause harm to workers. Step 3. Assess risk. After identifying the hazards, we assess the level of risk by evaluating the likelihood of the hazard occurring and the severity of its consequence. The risk level then calculated using the risk metric. Step 4. Apply controls. Once the risk level is determined, appropriate control measures are selected based on the hierarchy of control. The objective is to reduce the risk to an acceptable level and prevent accident. Step 5. Document HIRAC. All findings must be properly documented in the HIRAC form. These include details of the hazard, risk rating, control measures, responsible person, and completion dates. Proper documentation is important for compliance and future reference. Step 6. Review and update. Finally, HIRAC must be reviewed and updated regularly. Reviews should be conducted annually or whenever there are changes in work process, equipment, chemicals, or after an incident occurs. This process is continuous because workplace conditions can change over time, creating new hazards and risks. In summary, the HIRAC process can help organizations systematically identify hazards, assess risks, implement controls, and continuously improve workplace safety. After understanding the HIRAC process flow, let's examine the 5x5 risk matrix and learn how risk levels are determined during the risk assessment stage. Let's take a look at 5x5 risk matrix, which is used during the risk management stage of HIRAC. This metric helps us determine the level of risk associated with a hazard by considering two factors, likelihood and severity. The vertical axis represents likelihood, which measures how likely an incident is to occur. The scale range is from rare with score of 1 to almost certain with score of 5. The horizontal axis represents severity, which measures how serious the consequence would be if the incidents occur. The scale range from negligible with score of 1 and catastrophic with score of 5. To calculate the risk level, we multiply the likelihood score by the severity score. Risk equal likelihood times severity. For example, if hazard is possible, which is likelihood score of 3, and consequence is major, which has a severity score of 4, the risk score will be 3 times 4 equal to 12. Once the risk level has been determined, the next step is to select the most effective control measures. This is where the hierarchy of control becomes important. After identifying hazard and assessing risk, the next step is to select appropriate control measures. To do this, we use hierarchy of control, which ranks and control methods from the most effective to the least effective. The first and most effective control is elimination. This means completely removing the hazard from the workplace. For example, replacing a ergonomic CMP slurry with a non-toxic alternative chemical formulation eliminates the hazard at its source. The second control is substitution. If elimination is not possible, we can replace the hazard with a less dangerous alternative. For example, using a pre-diluent solution instead of concentrated hydrofluoric acid or sulfuric acid and reduce the risk of serious chemical exposure. The third control is engineering control. This control creates a physical barrier between workers and hazard. Examples include fume hoods, chemical storage cabinets, automated dispensing system, and locate exhaust ventilation. These controls help reduce exposure without relying on worker behavior. The fourth control is administrative control. This involves policies, procedures, supervision, and training. Example include standard operating procedure, permit to work system, course training, and the buddy system. Administrative controls help workers perform tasks safely. The final control is personal protective equipment, or PPE. PPE is considered the last line of defense because it protects the worker rather than eliminating the hazard itself. Example include chemical-resistant glove, face shield, safety goggles, lab coats, and respirators. When applying controls, organization should always start from the top of the hierarchy and work downwards. The higher the control is in the hierarchy, the more effective it is at preventing accident and injuries. In summary, the hierarchy of control helps us select the most effective measures to reduce workplace and risk and create a safer working environment. Now that we understand how risk can be controlled, let's look at a practical high-rate workplace example and see how these concepts are applied in real working environment. Let's take a look at a practical example of how high-rate is applied in the workplace, specifically in the chemical storage and CMP areas. The first hazard is chemical exposure from hydrofluoric acid and sulfuric acid. This hazard has a likelihood score of 3 and severance score of 5, resulting in a risk score of 15, which is classified as high risk. To control this risk, engineering controls such as enclosed storage cabinets, local exhaust ventilation, and emergency showers are implemented. Workers are always required to wear PPE, including acid-resistant gloves, face shield, and chemical-resistant aprons. The second hazard is CMP slurry inhalation or skin contact. This hazard has a likelihood score of 4 and severity score of 3, giving a risk score of 12, which falls under medium risk category. Control measures include installing local exhaust ventilation at CMP machines, implementing standard operation procedures for slurry handling, and enforcing two-person rule during operations. Workers must always wear N95 respirators, gloves, and safety goggles. The third hazard is incompatible chemical storage, such as storing acid together with flammable materials. This has a likelihood score of 2 and severity score of 5, resulting in a risk score of 10, which is also classified as medium risk. To reduce this risk, chemicals are segregated according to compatibility classes. Regular inspections and chemical inventory checks are conducted, and workers are required to wear standard lab PPE at all times. This example demonstrates the high rate helps us identify hazards, assess their risk, and implement suitable control measures to prevent accidents and protect employees. In summary, HIRAC is not just a documentation exercise, it is a practical tool that helps organizations make workplace safer and ensure compliance with OSH requirements. Having reviewed a practical workplace example, let's conclude this briefing by summarizing the key actions that management and employees must take to strengthen workplace safety and prepare for upcoming DOS audits. Finally, we have now reached at the end of this briefing. Let me summarize the key points and actions that need to be learned. Throughout this presentation, we discussed the importance of OSH, the responsibility under OSHA, the HIRAC process, risk assessment, and method of controlling workplace hazard. For management, there are 3 actions that must be taken. First, the company should appoint a qualified safety officer in accordance with OSHA 1994 Section 29. Second, a comprehensive HIRAC assessment should be conducted for all work areas, and the necessary control measures should be implemented within the required time frame. Third, if the company has more than 40 employees, an OSH committee should be established to support workplace safety programs and ensure compliance with regulations. For employees, there are also 3 key responsibilities. First, always wear the required PPE, especially when working in chemical storage area and CNP operation. Second, report all accidents, incidents, and near misses to safety officer as soon as possible so that corrective actions can be taken. Third, never handle chemicals without first reading the safety data sheet or SDS and completing the required safety training. By working together, management and employees can create a safer workplace, reduce the risk of accidents, and ensure compliance with legal requirements. In conclusion, safety is everyone's responsibility. A strong safety culture begins with awareness, commitment, and continuous improvement. That's conclude my presentation. Thank you. That's all.